Okay, so let's talk about the basics of Lean, and then we'll talk about the basics of Six Sigma a little bit later. Okay, so in this lesson, we're going to talk about what Lean is, what the different types of waste are that we try to address through Lean, and then a little bit about the history of Lean. Okay, so what is Lean? As a reminder, there's two goals in Lean Six Sigma. The first is to remove waste. That's the goal of Lean. And then reducing variation is the goal of Six Sigma. And so in Lean, we're trying to remove waste. That's our goal. And waste is sometimes referred to as muda in Lean Six Sigma. It's basically anything that does not add value for the end customer. We want to eliminate it. Okay? And then in Lean Six Sigma, we talk about 7 different types of waste that we're trying to address. And I'm going to provide you a quick overview here, but I'll go into more detail in a couple of minutes. Okay, the first element of waste is transportation, the unnecessary movement of materials in a process, moving those materials around more than is needed. Then there's the waste of inventory, buying more raw materials than we can immediately use, so they end up sitting around. Then there's the waste of motion, the unnecessary movement of people in the process. There's the waste of waiting, having to wait for the next step. Then there's the waste of overproduction. This is similar to inventory, except this is overproduction is producing more of our finished product than we actually need. Then there's the waste of overprocessing, performing more steps than the customer actually requires. And it's sometimes referred to as gold plating, doing things that they just don't really need. Then there's the waste of defects, producing products or services that are defective and that have to be corrected. One way to remember these acronyms, if it helps, is to think of the acronym TIMWOOD. Okay, so now let's talk in more detail about transportation, the first type of waste, the unnecessary movement of materials in a process. Now, if we have to move these things around too much, it's time wasted. Could be doing better things. And so what we should try to do is to have process steps positioned close to each other, so there's less movement required. So what's interesting is that there's more than 190,000 miles of liquid petroleum pipelines across the U.S. And you have to wonder, do we need all of that transportation of materials? Is there some more efficient path? That's what we should be thinking about. Is there, can we put the process steps closer together to minimize the waste of transportation? Then there's the waste of inventory. So purchasing raw materials, but not immediately using them, allowing them to just sit around, to go bad. You've got to pay storage costs on them. It gets expensive. So imagine if you build log cabins, you only want to keep the logs that you can immediately use. Those logs can rot if they sit around for too long. Bugs can get in them. They've got to be cut and dried fairly quickly and then used to build our home. Another example is if you produce smartwatches, you might decide that maybe it makes sense to stock up on sensors because you get a bulk discount or something. If you buy larger quantities, you get them cheaper per sensor. But you got to beware because technology changes fast and customers always want something better, faster, and cheaper. So you want to avoid buying too many materials. That generates waste. Then there's the waste of motion again, the unnecessary movement of people in the process. You can imagine it this way. Just think about all the time you waste throughout your life trying to find your car that you've parked in a mall, some other store. We want to avoid that, having to move around to try to find things or to get a process done. It shouldn't be like a mouse trying to find cheese. We want to try to eliminate or minimize the movement of people in the process. Now, one way that Amazon does this, limits the movement of people, is using warehouse robots. So rather than Amazon employees going to a shelf and picking out an item, these robots bring the items to the employee. And it allows them to store more inventory, ship more packages. There's lots of benefits of limiting the movement of people, eliminating the waste of motion, or minimizing it rather. Another thing to think about here is that more motion, for example, heavy lifting, it could mean more health and safety problems. So if we can minimize that motion, we could save costs in that way. Okay, then there's the waste of waiting for the next step in the process. We want to avoid that idle time. Have you ever arrived on time to a meeting that started late? Think about it. Time is money. You want to avoid that. Here's another question. Have you ever seen road workers standing around and waiting? They're still getting paid. We want to minimize that. An interesting example of this is with UPS. UPS trucks actually try to avoid left turns to minimize driver wait times. They know that left turns often require yielding to traffic, which results in the driver just sitting there and waiting, and the car idling using gas. So the question is, can we minimize the waste of waiting? Then there's the waste of overproduction, producing more than the customer actually demands. Now, one of the problems with that is that you've got to store the materials, and those materials could go bad. And so you've got to think about paying rent, utilities, security, and so on. It gets expensive. Now, Atari had this problem in the 80s. The company actually overproduced their ET game, and it almost brought down the entire company. They ended up having to bury some of their extra product in a landfill. Another example is in the oil industry. In 2014 and 2015, there was a global overproduction of oil, which drove down the price. And there were some other reasons for that, but that overproduction can drive down the price as well. Then there's the waste of overprocessing, doing more work than the customer actually requires. An example of this is, does your process include more approvals than are needed? Those approvals can delay things. So we think about what steps are we performing that aren't really important to the customer, and can we pull those out? The final source of waste is defects, issues that we've got to correct in our products. An example of this was with the Samsung Galaxy Note 7. There was an issue with the battery that caused some phones to catch fire. Now, one of the problems with this is that if we've got to repair, rework, or refurbish a product, we often can't sell it for full price. We've got to reduce it and sell it at a discount.